Another way to express how much of an element is in a compound is by the mass percent composition, often just called the mass percent. So this follows the same pattern as percentages in general, where it's the part divided by the whole times 100. So the mass percent of element X is the mass of X in a sample of that compound divided by the mass of the sample of the compound times 100%. So here we have a problem. A 0.358 gram sample of chromium reacts with oxygen to form 0.523 grams of the metal oxide. And we're supposed to find the mass percent of chromium. So the mass percent chromium equals grams of chromium divided by the grams of the whole sample times 100. We're using percent as a unit here. So what's the mass of chromium? Well, it's 0.358 grams. Right? They gave it to us right here. 0.358 grams of chromium. It's reacting with oxygen, and it's forming a compound with this mass. The compound weighs more because it's got chromium in it and oxygen. So that's the mass of the whole thing, 0.523 grams times 100. The unit gram cancels out. 0.358 divided by 0.523 times 100. 68.451%. 68.5% chromium. Any questions?
So you just divide those two?
Yeah, you find the mass of the element that you're interested in. You divide by the mass of the whole thing, times 100.
Would you have to write anything like the chemical formula for the compound?
No, you wouldn't. Mm-mm. You wouldn't need to write the chemical formula. So, calculating mass percent is all very nice. Why would we even want that? It's a very useful conversion factor. So I said earlier, if we want grams of sodium in grams of sodium chloride, we can go grams to moles to grams, and yeah, it's kind of long. But otherwise, we need some extra conversions. Well, the percent by mass is the conversion factor that you would use that would make that easier. If you don't know the conversion factor, though, if you don't know the mass percent, then it's not easier. But if they're giving you the mass percent, we can do it. So when we see 39%, percent literally means per 100. So 39 per 100. It's 39 grams of sodium per 100 grams of sodium chloride. So this is saying the mass percent composition of sodium in sodium chloride is. So it's the mass of sodium divided by the mass of the whole thing. 39 grams per 100 grams. This is a very useful conversion factor. This allows us to skip moles in the middle. But we can only use it if we know what it is. So FDA recommends that adults consume less than 2.4 grams of sodium. How many grams of sodium chloride can you consume still be within the FDA guidelines? That same question. Now we're told that the sodium chloride is 39% sodium by mass. This enables us to do this calculation faster. So we still want to write down what we've got here. 2.4 grams of sodium. That percent, 39% sodium. I want to write that as a conversion factor. 39 grams of sodium per 100 grams of sodium chloride. The question is, how many grams of sodium chloride? I've got these two numbers. This looks like a conversion factor. This does not. This is what I want to start with. This shows me the relationship between grams of sodium and grams of compound. And so I can do this in one step. Whereas without it, it took 3 steps. 2.4 grams of sodium times and a line. Grams of sodium chloride on the top, grams of sodium on the bottom. Units in place. I look at this percentage, 39 grams of sodium, 100 grams of sodium chloride. 100 grams of sodium chloride, 39 grams of sodium. This is not the only way you can solve this problem. This would have 2 sig figs. .2 grams of sodium chloride. We did not come up with exactly the same answer, did we? Last time, the other way, it was 6.1. This percentage only has 2 significant figures also, and so there's just a little bit less precision here. This is within plus or minus 1 in the last digit, though. Any questions? That's a good question. Thank you for asking. Where did I get this? This part, right? I got that from 39%. So percent. How many years in a century? 100. Per 100. So 39% means 39 per 100. It's 39 parts per 100 parts. So I can say 39 grams per 100 grams. It's kind of a shortcut in a way, but it really is what percent means. So if you think about 39 grams per 100 grams times 100 to make it a percentage, that's going to equal 39%. Does that make sense? Yeah. So anytime you're given a percentage, that's always a possibility. The overall idea for percent is the part divided by the whole times 100. And that's the same for any percentage. So if you're given the percentage, you can always say, well, it's that many of the part divided by 100 of the whole thing. And you can choose whatever unit you want in there. So, if a woman consumes 22 grams of sodium chloride, how much sodium does she consume? Sodium chloride is 39% sodium by mass. So this time we're given 22 grams of sodium chloride. And we're asked for grams of sodium. Right? Because we have this percent by mass, we can do this in one step. So 39% sodium, what does that mean? 39 out of 100. See, like if you were talking about, doctors who prefer white lab coats, 90%. That'd be 90 out of 100, right? 39% is 39 out of 100. It's just that we're not talking about something that makes sense, like dentists who prefer Trident gum or something. We're talking about grams of weird things, right? But the percentage is the same thing. So 39% sodium in sodium chloride. 39 somethings of sodium per 100 somethings of sodium chloride by mass. So these are masses, and put the same unit of mass in the top and the bottom. Usually it's most convenient to put grams there. So 22 grams of sodium chloride times. We're going from grams of sodium chloride to grams of sodium. Grams of sodium chloride goes down here because I want it to cancel out. Can you see that dimensional analysis might be useful? If it hasn't clicked for you yet how to work with these units, pester me with questions until it makes sense. It really will make the rest of the course much easier if you can handle the units. So I've got the units in place, then I look at this conversion factor, 39 grams of sodium. Well, this time grams of sodium is on the top, so I'll just write 39 grams sodium, and 100 grams of sodium chloride is in the bottom, so I write that down there. So much less thinking. Some of you are great with percentages, and you could do it a different way, that's fine. 8.58 is what my calculator is telling me. This is 2 sig figs, that's 2 sig figs. So 8.6 grams of sodium. That's a lot of sodium.
Oh my God.
Yeah.